So hello and welcome to Serverless Everything, Replatforming for Speed and Ownership. I'm Kirk Kaiser. I'm a Technical Evangelism Team Lead at Datadog. And joining me today is Tom Heyman, who is Head of Platform Engineering at Dunelm. And so today we're going to talk a bit about serverless and kind of why it has become so popular recently and what it is and what's going on behind it. So from my perspective, serverless is not a technology. It's a tool for increasing developer velocity. The goal with serverless is to allow developers to focus exclusively on delivering business value. So the idea here isn't so much a technology where servers don't exist. The idea here is let's empower people to ship their own code in smaller pieces. So why do we do that? Why do we care about empowering developers and giving them more autonomy? Well, the general idea with everything that we're doing in building products is, building this positive feedback loop, right? We build new things, we ship them to our users give us feedback, and then based upon that feedback, we kind of start to rethink the pieces of our product and where we should go next. So counterintuitive to maybe my prejudices, larger organizations are embracing technologies like serverless and Kubernetes to a much larger extent and quicker than we're seeing with smaller organizations. And, as a developer, my prejudice is smaller orgs are more nimble and can choose the most innovative technologies. So why would the most innovative technologies be being chosen by enterprises first in this case? And I think the real reason for that is that the enterprises are feeling that pain first and foremost of having larger teams, having to coordinate more things, having more pieces moving in general, and needing something to empower developers to be able to ship without having to coordinate everywhere. And so, over time, as a program or as an application or as a service gets successful, it becomes more interdependent and it becomes more difficult to do releases of software. So serverless really takes a very specific approach to dealing with these challenges and this complexity and to re-empower developers to ship code autonomously. And the way that it does that is kind of with minimal friction in infrastructure, right? The idea with serverless is that you're going to be forced to reason about your code in smaller pieces and to think less about the infrastructure and technologies underneath it and more about the direct value you want to have with the code that you're writing. So the idea here with serverless as a platform is that we're kind of getting out of the loop of our existing infrastructure and kind of the existing ideas and concepts that we use to deploy code and think specifically around the business use case and what we're building. And so again, with a traditional application, right, there are a lot of pieces to think of. And to a large extent, companies who are on technologies like Kubernetes, you still need to reason about all of these application layers. As a hypothetical, right, you're thinking in terms of Kubernetes base components, but in practice, once your code lives long enough, you will end up having to touch and think about all of these pieces. And at the very least, you have to make a decision about each one of these layers and what the best approach is. So rather than focusing exclusively on what should we be building and how are we going to get it out there sooner rather than later and in our users' hands, you're thinking about strategies at each one of these layers and what that might mean further on down the road for you. And so, the goal, the hype, if you will, with serverless is that, all of those layers become an API that is abstracted away. And rather than thinking in terms of all of the computers running things, you think in terms of the pieces and the components and the API that makes up serverless, and AWS will handle the scaling. And then you can just write smaller units of code that are written independently and deploy them on your own. And so the real goal here is kind of that individual empowerment and not having to coordinate releases as much as you may have to with, say, a monolithic application. But the real power of the serverless platform and ecosystem is how it fits within the greater AWS ecosystem. So your code never runs in isolation. You always need to have tools and components you hook it up to, right? And I think that the AWS ecosystem is evolving and giving us new abstractions to use and to not think about the underlying ways in which they run or are built. And so from my perspective, it's becoming more of writing code to APIs rather than writing code to run in a specific place. So rather than thinking of layers of abstractions, thinking in terms of building blocks. So I think of all of the AWS tools more as pieces of Legos to fit together, right? They have been designed to work together, and they have been designed in a way that you can use ideas as libraries. And for me, that's kind of a new pattern and a new approach with writing software. In that, from my background, I like to install all of these, caching layers and databases with very specific new things in them. But seeing at a code level within a serverless that you can just think about these components and manipulate them and use them within code is super powerful from my perspective. So what are those building blocks? So we have AWS Lambda. This, again, is kind of speaking to that application platform as an API from my perspective, right? You write your code, you upload your code, and your code gets run on demand via many different ways. AWS Fargate, right? Containers and the idea of containerization on demand and containers running on demand. Again, a very powerful way to reason about the method in which your code gets called, which might be different for you. Going down to the data layer. On a platform like Kubernetes, you have many different layers and places you can store your data. What I like about serverless is kind of limiting yourself to these already built primitives. So Amazon S3, right? You have a file, you want to store it, you put it in S3, it's there. It's taken care of, it's fast enough. Aurora serverless. This one to me is very interesting in continuing the idea of serverless databases. And then DynamoDB, right? We all know how well, having watched AWS sessions, DynamoDB can scale. Going back to integrations, right? One of the things that really blew my mind about serverless as a platform and as a new way of thinking about building software was seeing how you could use SQS within your code, within your serverless code. The idea of your code getting called via SQS in the same way you might define a route in something like Flask really was just incredible for me. Not thinking about all of the plumbing, and instead thinking directly about, okay, I have a queue, and I have this message that's on the queue, and I want to take it and I want to act directly on it. And I think that power of that deep integration with all of these building blocks within AWS really opens up new ways to think about building software quickly. And so, continuing on that idea, Tom has built a serverless first organization who use the tools of serverless to build autonomous empowered teams. And so I want to hand it over to Tom to talk a bit about his experience at Dunelm and moving over to 100% serverless infrastructure.
Dunelm is the largest homewares retailer in the UK. We have over 170 stores throughout the UK, and we recently replatformed our e-commerce platform and we went serverless first. At Danone, we're trying to help our customers create a home that they love. We're passionate about that as a business, and that includes everybody in tech. We are a bit ambitious about being a good company and to support our communities, but also to make sure that the decisions we make are for the longer term. We want to accelerate our customer-first transition, and that means technology is going to be a big part of that. We went from a monolithic e-commerce platform that was tightly coupled, couldn't scale when we had peak levels of traffic during Christmas periods. We struggled to deploy working software reliably, safely, and automatically. We only deployed once a month and it was quite cumbersome, and if there was a problem we always had to sort of fix forward. We relied on third parties to fix stuff for us on a day-to-day basis, and the feedback loop was generally very long and cumbersome too. So we decided to replatform Dunelm.com. We took the decision to go serverless first. We made some key decisions about using microservice architecture, going cloud first, and also to have APIs as one of our engineering principles. This gave us the opportunity to develop faster, scale quicker, deploy more frequently, and not couple systems and services together. So if one of the microservices or parts failed, the rest of the platform could continue operating. Serverless also took the hassle away from maintaining and patching and doing things like that, stuff that we're not massively interested in, and we can focus on new features and better improvements for our customers. So we went from component teams to outcome teams. We started with component teams, and this meant teams own things like basket, checkout, and payment. This got the services and the development teams underway, ensured standards and service ownership across the board. It did create dependencies between the teams. We managed this, but it did create a lot of overhead and coordination for things like end-to-end testing. We're moving on a journey now to go to outcome-based teams. This will give the teams more autonomy and ownership to drive our strategic decisions. It's less about giving work to do, more about understanding the problem and letting the teams respond through the innovation and creativity. It definitely needs a cultural mind shift. Teams need to learn other systems and push beyond their comfort zone. Some of the examples will be for the strategic decisions could be stuff like reducing deployment lead times and reducing basket abandonment by say 5%, 10%, etc. This next slide shows how we create working software at Dunelm. From the initial code commit to our automated testing, we build and test constantly through stages in our pipelines. We peer review and improve our code before we merge into production. This is how we give our teams autonomy to build our microservices. This empowers our developers to build new features. It gives our teams more autonomy, and with serverless, gives Dunelm the ability to build what we care about most and what we are most interested in. As we follow on from the previous slide, this is more detail about how we deploy working software into production. So as I talked about previously, we currently go through dev to testing to staging environments before changes go to production. Each of these environments will have stages and tests for our deployments, which our deployments have to pass before reaching production. If we notice an issue with a deployment and we see an increase in our error budgets, we've started to use Datadog Events API to overlay our deployments to help us find the root cause of issues. This is how we deploy to production. And to talk about serverless monitoring strategies, handing back to Kirk.
All right, thank you, Tom. I appreciate you sharing your story with us. So let's talk a bit about monitoring serverless with Datadog. The idea here of autonomous teams and people being empowered to ship on their own, as a hypothetical, it sounds great, right? Everybody wants to be able to go at their own speed and to deploy faster and to generally be unblocked by other people, right? Especially when we're developing software. But one of the trade-offs is that your servers no longer exist to be debugged when you need to debug them. So where do you begin when debugging? And more importantly, if you have multiple services involved in a bug, where do you begin to figure out what team or what service might be to blame and might need to be fixed? And even worse still, if you have a lot of people deploying code at the same time, how do you know who was the one who pushed last, who made that breaking change? And so we'll talk a bit about how Datadog approaches this. So the very first fundamental to monitoring and deploying and doing observability within Datadog starts with the AWS integration. So this, for me, is one of my favorite integrations at Datadog. As soon as you set up the AWS integration, you will begin to pull metrics from all of your AWS infrastructure. And so you will start seeing all of the things you have running within your AWS infrastructure with tags added to them, and with a whole bunch of information to be able to start to see what it is exactly you have going on within your infrastructure. And start to get visibility into what is happening. And so the very first thing that you kind of get out of that from a serverless perspective is this serverless view within the infrastructure. And at a very high level, it's a place for self-discovery of behaviors within a new system. So there is no need to communicate to the greater team, hey, I'm deploying a new thing. Everybody has this shared space to go and look and reason about what's happening. So there are a few things built into this serverless view. The first and foremost is you see invocations. When we're talking about billing and we're talking about performance of serverless, we generally speaking want to know how often our things are being called, how long they're taking, whether or not they're being throttled, how much memory they're using. And so all of these kind of things are filterable and sortable at a very high level. One of the things that's difficult about building software is that we're building realistically invisible things, right? Like we can't see the systems that we build. And so Datadog gives us literally visibility into the things that we're building and lets us start to reason about their behaviors, right? Even just having your base level graph up within your office starts to give you a feel for how your services behave in general. And that is a starting point to start to reason about what changes and when changes start to occur within your systems that without monitoring, without observability, you otherwise wouldn't be aware of. And you would, the way you find out about it is via your customers telling you. And so without that shared view, and this is something that I think I was missing in my own career earlier, without that shared view for data, the default for split teams is to, I think, fall back to blaming, okay, who was the person who deployed something last? Who was the last person to touch this service? Who was last? And that blame and deflection without observability, without somewhere to talk about, independent from the team, independent from opinions, really weighs down on developer velocity. And so I think that even something as simple as a serverless view where you can reason about deployments and errors and things that have happened is a huge first step. But the real kind of power within the platform for me is the deep integration with APM and logs and everything kind of in one spot. So in this case, right, one of the tricky things about serverless as a platform is that your code isn't being called directly. We talked before about how you can get your code called directly from a queue. However, how do you recreate a queue environment in practice, right? That is a very challenging thing to do, especially as a developer, to kind of recreate queue workflows, right? So APM and AWS integration allow us to see where these requests are coming from. So in this case, what we're seeing on the screen here is what's called a trace. So at a very high level, we see that the trace begins with the first span, which is being called from an API gateway. And so it's labeled that an API gateway was called, and that API gateway then invoked a specific AWS Lambda called coupon staging. Within coupon staging, we have our own set of tags, right? We can see the status code, a request ID, the resource name of it, and more importantly, and kind of more interestingly, we can see a graph of the request as it comes through with our systems. So we see the top or parent level span, which calls the child span. So what does that do for us? Well, it does a few very critical things. And the most important of which is give us the context for this service map. And it also gives us this way to reason about our units of work as, or our requests as units of work, as complete units of work. So it's a thing that comes into a system and goes through another system, and we see that as one entire unit of work. So the service map is actually made up of those parent-child relationships. At all of those traces as they come in through our systems, we start to build up a dependency graph. And so we can see over time, as we make new deployments and as we add new microservices, they all get added to this service map. And so here there's a couple things to call out and to note. There's different icons for different types of services. So we have web services, database services, cache layers, lambdas or serverless functions, and then custom. So we're reasoning here in the service map about services. So the underlying platform of what a service is running on doesn't matter so much as the thing the service is accomplishing. Along with that, there's a couple things going on here, right? That some of the rings are colored, some of the rings are different sizes. So the sizes give us a way to reason about the requests per second. If we have new deployments and we're worried about scaling up, we can kind of look into our dependencies and see where there might be further bottlenecks. And the red and green. So a red ring means there's at least one service monitor that's failing on that service. The green means that all monitors are passing. So this is really interesting because with APM, by default, you can add suggested default service monitors for things like latency, right? When you move to a distributed system, when you move to microservices, if you have a lot of those systems returning very high latency, it can build up and it can accumulate into extremely long latencies. And so by default, having these latency thresholds or agreements that you want to have, you can see right here on the service map what's going on and where you need to address things within your systems. So one thing that's kind of new, at least for me, it has been the idea of Jamstack and the idea of pushing mostly static assets out to a CDN and having these microservices respond to requests. And having those smaller API services do pieces of the business logic. Datadog has added real user monitoring to grab kind of the end user's experience on the front end. And so I think that following that Jamstack and following that pattern, there will be kind of the continued growth of the entire experience for the end user from front-end code to serverless infrastructure all the way down. And having that entire view of the requests in each piece of code and allowing you to jump up and down layers of abstraction within Datadog is a very powerful tool to be able to do exactly what we talked about before, right? Which is empowering developers to ship autonomously, to find out their own solution to problems without having to involve other teams, being able to explore and find answers to their own problems. One of the tricky things that we've kind of mentioned before about being able to see is deployments. How do you track deployments over time? We recently launched at Datadog a way and a new view to be able to track your AWS Lambda versions over time. So in this case, it lives under the infrastructure tab within Datadog, and we can see deployment events, invocations, errors, and duration. So we can track over time, we can go right into a serverless function and see what has happened here recently. What has changed recently? Who was the last person to deploy something? What was that about? And so I think as APM adds more versioning and deployment tracking, we will continue to see this be a very important tool in diagnosing what happens over time and where changes are coming from. And again, it kind of gives us an audit log, if you will, of what has been happening within my infrastructure. What has the story been for this specific Lambda? Have we been working on it intensely for the past 2 weeks? Have we not touched it for 3 months? I think all of that context is important, right, when you're trying to discover the story about what is going on within your service. Extremely exciting for me personally is the newly released Zero Instrumentation Serverless with the AWS SAM and CDK integrations. So the idea here is that right out of the box, we will, via configuration, automatically add tracing to your code and ship that over to Datadog. So by adding some configuration details to your AWS SAM macro, you're going to have tracing and visibility into everything. So in one go, without any code editing, which is always it's always a bit of work, right? Without any editing of your code, have all of this visibility just dropped right into your infrastructure and your serverless lambdas. Continuing on there, the same thing, we're doing alerts as code with AWS SAM. And again, one of the things that you really need to do as a team and really want to do is have a standardized way of working and reasoning about all of these services. When you have all of these microservices deployed, you want to have a shared language and a shared understanding. And so I think alerts as code with AWS SAM is an amazing step in that direction, and an amazing step in the direction of having all of your infrastructure and alerting as code. So once again, thank you so much for coming. Thanks again, Tom, for all of your story that you've shared with us today. Enjoy the rest of reInvent.